Hello. So in this video, we're going to be looking at solving systems of equations using substitution method, which is also known as solving algebraically, but we're going to be using the substitution method in this video. To jump right into our first question, we have y is equal to x and y is equal to negative 5x plus 1. Essentially, what we do with substitution is we get the value for one of the variables, and once we get the value of, say, y, which we know here is equal to x, we can substitute our values of y in the equation to equal x. So y is equal to x. So I would I would replace our y values with x in my second equation. So that would be y is equal to x. So my y in my second equation would become x. So it would be x is equal to negative 5x plus 1. Now, just like any other linear equation, I can take my 5x to the other side, so it becomes x plus 5x into 1. So 5x plus x is x, which is equal to 1. Divide both sides by 6, so I can isolate my x. My x is equal to 1 over 6. I can also, so now I have my x value, but I also have to find my y coordinate. So I have x is equal to 1 over 6, but because I have my equation y is equal to x, it's very easy to find my y coordinate because x is equal to 1 over 6, so y is 1 over 6 as well. So there's my answer. 1 over 6, 1 over 6, my solution of my interest. That's my solution for this first problem. Okay, so my second problem is a little more complicated. It says x plus y is equal to 3 plus 3 and y is equal to 2x plus 3. They're asking for they want us to find the point of intersection using the method of substitution. So the first thing we would do is we know y is equal to 2x plus 3. So y is equal to 2x plus 3. So what I would do with this value is I would plug wherever I have a y value, I would make it 2x plus 3. So essentially in my first equation, which is x plus y is equal to 3x plus 3, I would change my y for 2x plus 3. So I have x plus 3 is equal to 3x plus 3. Now I can add my like terms. 2x plus x is 3x plus 3 is equal to 3x plus 3. I can bring my 3x to this side, so I have 0. And I can bring my 3 to this side, and I have 0. So because I have 0 is equal to 0, I have no intersection. No intersection point. So there's no solutions for this function. For this system of equations because uh, I don't get a solution. I get 0 is equal to. That says nothing about the intersection points. All right. So the reason why we got 0 and 0. Sorry, wait. Let me just. So solution can be either no intersection points or infinite intersection points. Sorry about that. So we're gonna check whether it has 0 intersection points or infinite intersection points. So now let me isolate my x variable in my in my first function. So I have y is equal to 3x. I bring my x to the other side, so I have negative x plus 3, which gives me y is equal to 2x plus 3. And oh my, so if you can see, both my equations are the exact same. Y is equal to 2x plus 3. That means my line, they're the exact same line, which means I have infinite solutions. Sorry about that. So I have infinite solutions, infinite intersection points for this question. Alright, moving on. I have y is equal to 3x plus 4 and y is equal to negative 2x plus 1. At any point of the video, you can pause the video and try these questions yourself. So y is equal to 3x plus 4 and y is equal to negative 2x plus 1. I know y is equal to 3x plus 4. So I'm going to plug in that y value into my second equation, which would be 3x plus 4 equal to negative 2x plus 1. Of course, linear equations, I can take my negative 2 to this side, which would become 3x plus 2x. I can take over my 4 to this side, which should become negative 4, so negative 4 plus 1. 3x plus 2x is 5x. Negative 4 plus 1 gives me negative 3. Now I have my x value, which is equal to negative 3 divided by 5, because I divide both sides by twice my x. I have my x coordinate now, but I also have to find y coordinate for my intersection. To find that, I can use my function. It would be easiest to use in this case. Y is equal to negative 2x plus 1. So I know x is equal to negative 3 divided by 5. I plug that into my equation. I live to a function rather. I have negative 2 times negative 3 over 5 plus 1. Y is equal to negative 2 times negative 3 is 6. Positive 6, sorry. So positive 6 plus 1. 6 5 plus 1. Now I can find my LCM. 1 over 1 times both sides by 5. So I have 5 divided by 5. So y is equal to 11 divided by 5. That's my y coordinate in my intersection point. Now I know my x, which I found earlier, which was negative 3 divided by 5. So my intersection point is negative divided by 5, comma 11 divided by 5. There we go. Right, moving right along. Our next question is y is equal to 4x minus 10 and y is equal to 2x plus 1. So I know that y is equal to 2x plus 1, so I'm going to substitute y is equal to 2x plus 1 into my y variable for my first function here. So I have 2x plus 1 equal to 4x minus 10. Bring my 4x to my other side, so I have 2x minus 4x. Bring my 1 to my other side, so I have negative and minus 1. 2x minus 4x gives me negative 2x. Negative 10 minus 1 gives me negative 11. X is equal to negative 11 divided by negative 2. Negative negative become positive. I'm left with 11 divided by 2 is equal to x. To find my y coordinate, I need to substitute x is equal to 11 divided by 2 into my second function. So y is equal to 2 times x, which would be 11 divided by 2, plus 1. I can cancel 2 and 2. So y is equal to 11 times 1, which is 11, plus 1. Y is equal to 12. So I know my intersection point is 11 divided by 2, comma 12. And there we go, that's my answer. And that was solving systems of equations by substitution.